Welcome back to another episode of our STEM Virtual Experiment series. I am Xavier Murray, a Technical Information Officer of the Scientific Research Council. And today I'm joined by Ms. Melinda Levy.
Hi everyone, my name is Melinda Levy and I'm a fourth year student at the University of Technology Jamaica doing a BSc in Applied Sciences.
Right, today we'll be exploring electromagnetism. Now, this is a fundamental force of nature, and it used to be studied separately, electricity and magnetism, but now it is consolidated. Leading up to that point, there are key discoveries and key scientists who helped us come to this realization, starting with Ornsted. Ornsted, he observed that when an electrical current is passed through a wire, the needle on a compass moves, thereby establishing an interaction between electricity and magnetism.
Then we moved to Michael Faraday. This scientific genius discovered that a moving magnetic field induces an electric current in a wire, and we got electrical induction. This led to the discovery of electric generators and motors, and without these, we'd be hand cranking everything today.
Quite right. Additionally, we had Maxwell, James Maxwell. He created what's known as the Maxwell equations, and they describe the interaction between electricity and magnetism. Through his equations, we're able to predict the presence of electromagnetic waves long before we had the ability to detect them.
Last but not least, cosmic genius Albert Einstein. He looked at magnetism and decided, this is just electricity in disguise from a different perspective. So magnetism is electricity in motion.
And this culminates in quantum electrodynamics. This is our most recent and up-to-date model of electromagnetism, and it seeks to explain how charged particles interact with each other using photons. Now, in today's video, we aren't going to develop an industry-grade electromagnet.
Oh no, we are doing a downsized version from instruments that you can find in your home.
Right, so these are common household items. We have our C-cell batteries, iron nails, and a length of copper wire. So Melinda will go through and demonstrate how we can create this electromagnet and then assess its strength by seeing how many paper clips she can pick up. And she'll also determine the various factors that affect the strength of this electromagnet. So Melinda,
Thank you.
the floor is yours.
Thank you. So we have our metal nail, and it's just a metal nail without electricity flowing through it. And I can touch my paper clips and nothing happens because it's just a piece of metal. Now, if I were to wrap a metal nail with a copper wire, creating coils, which is known as a solenoid, wrapping it many times as I can, and attach it to a battery. And I'll be doing one cell first. So attaching the cell with the wire on both the ends to allow the electrons to flow. So imagine the electrons as little runners, basically. One end here, one end here. And I am able to pick up the paperclip with one. Now, I am going to be putting this down, adding more coils, and also doing the experiment with 2 cells. So I attach this here, and then here. And I'm supposed to be able to pick up 2 of the paper clips. There you go, with 2 cells. Moving on to more coils and an even stronger battery cell. That's 3 cells connected in series. So one end of the wire here, another end there, multiple cell coils, and I should be able to pick up the 3 paper clips. There you go. 3 paper clips were picked up. Of course, there are different factors that can affect the strength of the wire and the strength of the magnet. These are the coils, number of batteries, and that's the end.
Thank you very much, Ms. Levy, for being here.
Thank you for having me.
And as she so aptly demonstrated, the strength of the magnetic field can be influenced by the strength of the batteries, as well as the number of coils placed upon the iron nail. Now, if you're a teacher and you want to co-opt this for your lesson, we recommend not going through the full gamut as we have. Instead, give them 1 battery, 2 batteries, 3 batteries, varying lengths of copper wires, and ask them to think up various configurations that they could improve or enhance the strength of the magnetic field.
This fosters scientific discovery in the students.
Very much so. I would like to thank Melinda once again for being here.
Always a pleasure.
And sharing her knowledge with us. Please remember to like, share, and subscribe. And join us next time on another episode of our STEM Virtual Experiment series.
Thank you for being here.